Hello and welcome to Thought Leaders, the lecture series presented by Space Center Houston and sponsored by UTMB Health. I'm Becky Trout-Umbehagen, Director of Community Engagement for UTMB, and I'm so glad you are with us. Our topic today is innovation, specifically the innovations and business strategies guiding the current wave of space exploration. This story will be told through the lens of TransAstra, a revolutionary research company exploring space sustainability and the growth of space-based industries. At UTMB Health, innovation is and has long been a key component of our success. We view innovation as the fourth pillar of our mission, a mission that also encompasses education, biomedical research, and patient care. Our Office of Innovation is in place to accelerate the health-related discoveries and biomedical inventions of UTMB researchers and clinicians, moving them safely and quickly from the bench to the bedside to benefit people and society. Through technology transfer, mentoring, providing funding and resources to encourage business development, UTMB is working rapidly to bring our innovations to the forefront. UTMB is driving biomedical innovation to transform medicine, just as tonight's presenter, TransAstra, is leading the next wave of space exploration. Space Center Houston's Thought Leaders series continues to expand our understanding of aerospace and the worlds beyond our atmosphere. It encourages us to consider how the impossible becomes reality and how the fruits of innovation impact our lives on Earth and in space. I look forward to tonight's intriguing presentation. Thank you for joining us.
Hello, I'm William T. Harris, President and CEO of Space Center Houston. Thank you for joining our Thought Leaders Series program, Engineering the Future of Space with TransAstra, presented by the University of Texas Medical Branch. Our Thought Leaders series features space and science experts together to offer valuable insights into space exploration and human spaceflight. As the official visitor center for NASA Johnson Space Center, we share the journey of human spaceflight and space exploration, past, present, and future, with over 1.3 million visitors from around the globe. As a nonprofit organization, we house more than 400 space artifacts and provide behind-the-scenes tours of NASA Johnson Space Center's working facilities. We also offer robust STEM learning experiences through our education programs. We're dedicated to making science learning and space exploration accessible to everyone, and we proudly celebrate more than 30 years and counting as Houston's leading global destination center that brings people and space closer together. This episode of our series features experts from TransAstra, a global organization pioneering the development of game-changing technologies in the areas of orbital logistics and space resources. Their work is primarily funded through NASA's NIAC program with the aim to drive transformative advancements. Among the focus areas of TransAstra is turning space debris into valuable resources to help advance humanity's efforts to move industry beyond Earth. I'm thrilled that we're joined today by three executives from TransAstra. Dr. Joel Searle is the founder and CEO of TransAstra Corporation, with a distinguished career spanning both industry and academia. Joel has been instrumental in developing innovative propulsion systems and space mining technologies that promise to revolutionize the utilization of space resources. Under his leadership, TransAstra has become a Y Combinator-backed company, successfully raising over $10 million in private investments and securing more than $10 million in grants and contracts from NASA and the U.S. Space Force. As a seasoned entrepreneur and technologist, Joel has a deep understanding of both the technical and business challenges of space exploration. He's been awarded 7 NASA Innovation Advanced Concepts, or NIAC, fellowships, underscoring his role as a thought leader in space innovation. Our second panelist is Alex Pilmer, Chief Business Officer for TransAstra. Alex oversees investor, customer, and partner relationships, as well as human resources and legal affairs. Previously, Alex was an equity partner at Kirkland & Ellis LLP, an elite global law firm. During his diverse legal career, Alex has handled a wide variety of legal and business matters relating to technology, finance, commercial, real estate, and securities. His clients have included some of the world's largest and most sophisticated technical companies, private equity funds, as well as startup ventures. Our third panelist is Nicole Shoemaker. Nicole is the Vice President of Strategic Partnerships and Business Development at TransAstra, where she plays a key role in driving the company's growth in space logistics and asteroid mining. With a strong track record in securing R&D funding and commercial revenue, she's built multiple technology businesses from the ground up, generating millions of dollars in revenue. Previously, Nicole served as a research specialist at Texas A&M University, where she led a lunar engineering initiative that secured over $3 million in competitive funding from NASA and other sources. She also founded and managed the Texas A&M Lunar Surface Experiment Program. She holds a Bachelor of Science in Earth and Atmospheric Sciences from Georgia Tech and has extensive experience in research and program development. Nicole has conducted field research in zero gravity and the Arctic and is passionate about Earth and space exploration. Welcome our panelists. We're so excited to hear from you today. First, Joel is going to provide us with some background about TransAstra and this remarkable new company. Joel, I'm turning it over to you.
Fantastic. Well, I'm delighted to be here, and I'm talking to you from our laboratory, which we call the Hive. Here in the laboratory area, which is about 4,000 square feet. You can see behind me some of our engineers. The guy on with the yellow hard hat there is Dr. Thibaut Talon. He's our chief of mechatronics. They're working on our capture bag, which is an important technology that we originally invented for capturing asteroids. But first, we're going to be using it to clean up orbital debris in orbit around the Earth to make navigation of spacecraft safer. Very exciting thing is that we've been selected recently by an organization called CASIS to actually fly our capture bag on the International Space Station as the first in-space demonstration of capture bag technology. You can see it's a picture of me and some of our core staff members, including some of our investors. Sharp-eyed viewers will see the fella in the Hawaiian shirt. That's Matt Bellamy, the front man of the rock band Muse, and he's actually one of the investors on our cap table. And he's actually one of the investors in the company. We're very proud to have him as a partner. So the company, we've got about 23 full-time engineers. So we're still a small but rapidly growing company, led by a team of 4 PhDs, 3 from Caltech, 1 from MIT. And then you can see the highlighted pictures on this slide include me. I'm the founder and CEO, Alex Pilmer, who's here today. He's our chief business officer, and Nicole Shoemaker, who's our vice president of strategic partnerships. So we are a very innovative company. Among the core engineering staff, we have between us well over 50 issued patents. And the company itself has about 20 patent applications that we've prosecuted over the last couple of years. 14 of those have been issued so far, and we're anticipating another 10 or so in the next year or so. TransAstra's vision is a world that is enriched by the resources of the asteroids. There are enough materials in the asteroids to provide all the mineral wealth that humanity needs for the next 1,000 years. We could build actually worlds in space out of the asteroids that have 1,000 times the carrying capacity of the planet Earth. That's the vision. But what we're doing right now is delivering hard-nosed engineering products on time and on schedule for customers who need it now. And the issue here, and the plan here, is that we have engineering products in 4 fundamental areas that when you add them all together, add up to asteroid mining. But they're important businesses in the here and now for our customers at NASA and the Space Force. And we call these 4 fundamental areas detect, capture, move, and process. To be an asteroid mining company, you have to be able to detect a lot more asteroids than we've been able to discover so far as a species, which means you need better telescope technology. Once you get to the asteroid, you've got to be able to capture it in a bag because you can't land on an asteroid. There's not enough gravity. And most asteroids are made of piles of rubble and sandcastles, not the kind of rocks that you see in science fiction movies. So you can't dig in or auger or land. You've got to capture the asteroid in the bag, then you can work on it. But of course, you have to get to the asteroid, and once you harvest the material from it, you've got to get that material back. So that's the move challenge that we're overcoming. And then lastly, materials processing technology. So detect, capture, move, and process are the four fundamental problems that TransAstra is solving. And we're building businesses around each one of those in the here and now. I want to talk to you mostly about two of those problems, detect and capture, today. So as part of the detect solution, we have our current Sutter telescope network. In the introduction, you said TransAstra is a global company. In a way, that's true, even though we're a relatively small company here in Southern California, in the San Fernando Valley. We do operate a global network of telescopes, and that network is growing all the time. Right now, we have a compound telescope with 4 optical tube assemblies, 4 telescopes on it in California, another one in Tucson, and another one in Australia. You can see in the video in the upper right of this image, the 6 telescope unit that's currently operational in Australia. And we use these telescopes as test beds to develop our technology for finding and prospecting asteroids more cost effectively. And our goal is to find thousands of mineable asteroids that will enable a massive gold rush to space for asteroid mining. But in the here and now, we are on contract with the Space Force to find and track targets in cislunar space that could be security threats to the United States, or navigational hazards, or just better understanding of what's out there in all the different countries that are operating spacecraft in cislunar space, so we have better navigation and safety. Here you see another video of the Sutter telescope that's deployed in Australia. That's when it was here in our laboratory, the Hive. And in the center of that image, you see a video that's made of still images that we took with our telescopes. And it shows how we can digitally process those still images to find moving objects in space. Essentially, if you look at that animation, you'll see that you can see the stars in the background are initially points. But we're looking for something that's moving relative to the background stars. So we guess thousands of different possible trajectories that asteroids or other lost objects could be floating through the frame there. This happens to be one guess of a velocity vector. What you see is that as the computer runs and processes this stack of up to 125 images, it's processing it for motion, and when it does, those still stars in the background turn into streaks. But the magic here is that the moving object turns into a stable object that we can get a good exposure on. And we can find things with very inexpensive commercial off-the-scope telescope assemblies that would otherwise take expensive multi-million-dollar systems to work. We do deep technology on our telescopes, but we also do very practical engineering. We've integrated our telescopes into something that we call the Turnkey Observatory, or TKO, which is a complete modular observatory in a can. We're developing these systems here in the Hive and then deploying them globally. The first one is in prototype out there in the parking lot. I might be able to show that to you later today. And what you can see is that we can put as many as 3 turnkey observatories, each with 6 telescopes in it, into a single shipping container, ship it out to a site, and have a full observatory set up in a matter of days. We think this is the most practical and cost-effective way to deploy global observatories for rapidly building out observatories all around the Earth to keep track of what's going on in the night sky. Next thing I want to talk to you about is our scalable capture bag technology. So, as I said before, if you want to mine an asteroid, the first thing you have to do is fly up to it with your spacecraft, deploy the capture bag. The capture bag is an inflatable structure. You can see a prototype here being tested in the laboratory behind me. It comes out of a very small enclosure, opens up a large bag. The spacecraft flies up to the asteroid, matches velocity with the asteroid, matches rotation with the asteroid, flies the bag over the asteroid, closes the bag, cinches it down, and then the spacecraft uses its propulsion system, its attitude control system, to despin the asteroid. Once we have it in the bag, we can use our material processing technology to extract the valuable materials for return to cislunar space, the region of space around the Earth, where it can be used to support NASA missions and private sector missions. Or if we're on a mission to mine metals from the asteroid, such as platinum group metals, things like gold, platinum, that sort of thing, we can capture those metals and bring them all the way back to the surface of the Earth to profit the metals industry here on Earth. That's the idea of the capture bag. Now, it has all kinds of practical civil and defense applications in the here and now, and that's why the Space Force and NASA are paying for this today. The Space Force asked us, what if there was a piece of debris that was small, maybe the size of a basketball, that we wanted to capture and clean up because it's a navigational hazard in space? How small of a capture bag could you make? And what we realized is we can actually package a capture bag into a box about the size of a Rubik's Cube that they can open up and capture small spacecraft and pieces of debris. We've also done scaling studies that to build capture bags that can, as big as this, that can actually be packaged and carried on relatively small spacecraft, a spacecraft the size of a go-kart. Then if we really want to go after big things, something the size of a small mountain in space, we can actually build capture bags that can capture full asteroids, cinch them down, despin them, and then we can do our mining processes on them. So in the short term, capture bag is for cleaning up orbital debris and other things that are not where they should be in space, helping private sector and government customers who want a way of disposing of their satellites at their end of mission. Those are the near-term applications. And later, it's all about asteroid mining. So it might be fun to play this video. So you see the gantry system behind me is designed to test how the capture bag can be used to capture spinning or tumbling objects. The video that you're watching is a video of a mass model that our engineering team here at TransAstra has developed that can simulate a rocket stage, quite a heavy rocket stage, tumbling and nutating and twisting in space so that we can show how the capture bag can fly up to the mass, capture it, contain it, and then dispose of it or bring it to a recycling center to be recycled. And actually, our asteroid mining technology is perfect for recycling the metals in spent rocket stages and spacecraft. So we're really excited that NASA CASIS has selected us to fly our capture bag on the space station in 2025. And we think that's going to be an extremely exciting demonstration of the capture bag in space that will lead to near-term commercial and defense applications and later open the solar system to asteroid mining. One thing that we shouldn't forget is our optical mining technology and our solar forge concept. Our vision is a world in which the resources of the solar system are available for humanity. First, those resources will be used by companies building systems, spacecraft, and using rocket propellant to get around in Earth orbit. And later, we'll be harnessing those resources, processing the materials, and building factories to build giant space stations and giant satellites that fulfill many functions not currently performed in space today. The cornerstone of our long-term plan is something that we call Solar Forge, which is a system that uses sunlight and the vacuum of space to process materials and get them ready for manufacturing processes in space. So that's a little bit about who we are as a company, what our vision is, what we're working on today. Now I'd like to turn it over to my colleagues, Alex and Nicole, to tell other aspects of our story.
Joel, thank you so much. That was absolutely fascinating. I have so many questions, and I'm very impressed by the business proposition of what you're doing. So next, we're going to hear from Alex.
Thanks, William. So I am a lawyer by training, although I don't really practice law anymore. My role at the company is all things that don't have to do with technology, which is fortunate since I'm not an engineer. But I'm going to speak for a few minutes about what are some of the legal implications of what we're trying to do at TransAstra. As Joel just described, we have all sorts of amazing technologies that we're building and putting together right now. But how do we go about making this a business that complies with the laws? The first picture I've shown here is the actual signing of the Outer Space Treaty of 1967, which is basically the cornerstone of just about all space law today. I'm going to talk a little bit about that and its implications for our business going forward. So, the Outer Space Treaty of 1967 came into existence through the United Nations. The United Nations has a committee called the Committee on the Peaceful Uses of Outer Space, and it played a pivotal role in advocating for a peaceful, non-militarized approach to space. At the time, there were many nations, particularly non-aligned countries, who were seeking assurances that the benefits of space exploration would be accessible to all humanity and not just dominated by the superpowers, at the time, primarily the US and the Soviet Union. The UN helped draft the treaty and then facilitated international discussions to build consensus with countries across the world seeking space as a, quote, global commons that should be protected from national claims and militarization. So, the Outer Space Treaty establishes that outer space is, quote, the province of all mankind. That is one of the terms that is most associated with the Outer Space Treaty. It was initially signed by the United States, the Soviet Union, and the UK. It has since been signed by over 100 countries, including China, India, and Japan, all of the major spacefaring nations. The Outer Space Treaty provides that no nation can own the moon or any other celestial bodies. And again, I put the quote up here, probably the most recognized quote from this treaty: outer space, including the moon and other celestial bodies, shall be free for exploration and use by all states, and there shall be free access to all areas of celestial bodies. So, you see the US flag on the moon. There's nothing in the Outer Space Treaty that prohibits us from doing that, but we cannot, as a country, claim the moon to ourselves, nor can any other country under the Outer Space Treaty. Some of the other key provisions of the Outer Space Treaty include freedom of exploration and access, freedom for scientific investigation, avoidance of harmful contamination, and no military installations on celestial bodies. Now, the Outer Space Treaty is only a beginning, and it has significant limitations. So, for example, what's not covered by the Outer Space Treaty? So, space traffic management, orbital debris cleanup, jurisdiction over legal disputes, military uses of space assets. These are not covered under the Outer Space Treaty, with one little exception. The Outer Space Treaty does prohibit nuclear weapons in space. And then there's ambiguities. There are ambiguities in the Outer Space Treaty. For example, how can it be that a celestial body like an asteroid is free for exploration and use to one state, let's say the United States, while simultaneously requiring free access to all areas of that asteroid, presumably to a different country? The Outer Space Treaty doesn't answer that question. Or, most importantly to TransAstra, how can a private company extract and own resources such as water, minerals, or metals from a celestial body like an asteroid? Well, that brings us to our next slide. And this is the United States Commercial Space Launch Competitiveness Act of 2015. I selected a particular image here for a reason, and most of you who are watching this will recognize immediately what this image is. This is just from a few weeks ago now, the Starship being caught by the chopsticks. One of the most impressive images of a space technology demonstration from recent memory. And I'd like to take a moment to kind of think back as to what made that possible. Tremendous amounts of financial and human capital had to be invested to make this happen, and tremendous amounts of risk had to be taken. And in one small measure, the CSLCA, this statute, helped pave the way for this to happen by easing regulatory and legal restrictions. How did it do that? Well, this statute promotes commercial space exploration. It supported private sector activities in space with reduced regulatory barriers, encourages commercial space mining and exploration. It specifically provides that it aligns with the Outer Space Treaty, thereby ensuring that we comply with our country's international obligations. And most importantly, it encouraged private innovation, private sector innovation, which here at TransAstra we believe is crucial to the future of space exploration. But there's one particular provision of this statute that we care about most. And this is 51 USC section 51303. As a lawyer, I had to actually quote the statute. I know nobody else would care about that number, but this is where it is in law. And this is the actual statute. Answers the question, can we, as a private company, can we engage in asteroid mining? And the statute reads, a U.S. citizen engaged in commercial recovery of an asteroid resource or space resource shall be entitled to any asteroid resources or space resource obtained, including to possess, own, transport, use, and sell. So I started talking about the Outer Space Treaty and mentioned that there is nothing in there that specifically says, for example, that we as a private company can mine asteroids for their resources. But the United States Congress has passed a statute that specifically gives that authority to us. Now, we are still in the very early stages of what we believe is going to be a very robust space economy. We're also in the very early stages of a legal and regulatory framework for that economy. There are a lot of unanswered legal and regulatory questions. I've listed some of the few of these unanswered questions, and I could probably have about 20 or 30 slides on this particular topic. In a way, we're a little bit like the Wild Wild West, or maybe European expeditions from the 1500s. We're going into new lands where the rules are not firmly set. And I don't profess to have answers here. One of the biggest challenges I think we're going to face is that due to its very nature, these issues will require a decent amount of international coordination and agreement. And in today's world, that will be a challenge to make to come to fruition. So, William, I do look forward to your questions, but those are my thoughts on the legal and regulatory issues affecting us right now.
Thank you, Alex. I'm always intrigued by the legal issues around exploration, and it is really like the new frontier in so many ways. And it's really interesting how all has evolved so quickly since the signing of that act in 1967. So I also have a lot of questions for you as well. But first, let's hear from Nicole.
Okay, great. Thanks so much, William. It's such a pleasure to be here. And I'm going to try to take a few minutes to lay out the landscape of this new business of new space, the new space economy. And if I were going to pin the beginning of the new space economy to a time, I would have to say it's 2018. Now, there have been various periods since Apollo that we thought it might get going, but it really didn't. And it's always an evolution. But there were a series of events that came together that really made 2018 seem like the point at which point there was no going back. And I have to explain one thing that happened at the end of 2017 that picks up on what Alex was describing. And that was when the first Trump administration restarted the National Space Council and issued Space Policy Directive 1. This was at the very end of 2017. And Space Policy Directive 1 set a new focus and priority for NASA to return to the moon and establish a permanent human and robotic presence, specifically with an eye forward to then go to Mars and do the same. And I'm going to talk about why and why now in a moment. But this is the series of events that happened right after that. Early 2018, the world watched as SpaceX flight tested Falcon Heavy and landed not one, but two boosters in perfect formation. And I remember being breathless watching it, and millions of others did too. It seemed like so sci-fi at the time, and people rumored that it was CGI, but it was real. And this was the mission that launched the Tesla Roadster into a heliocentric orbit. And it's now in an orbit that crosses both Mars and Earth orbits. And Musk's ambition was really to inspire the public about what the possibility of something happening, new things happening in space. And that's really what he did. And this created, I think, a profound shift in people's awareness of what was possible and what was coming. And this was only 6 years ago. What happened right after that in May and June were Space Policy Directive 2 and 3. So following, again, Alex's comments, Space Policy Directive 2 was really about streamlining regulations on the commercial use of space, reforming launch licensing, satellite regulations, other commercial space activities. And then quickly thereafter, Space Policy Directive 3 created the National Space Traffic Management Policy, which focuses on space traffic and specifically on debris management. So minimizing debris to ensure safe and secure access in operations in Earth orbit. And we're going to talk about that a little bit more later too. And then in September, in response to Space Policy Directive 1 for NASA to return to the moon, NASA put out a call to the private industry, including startups, not just big government contractors, to compete to build lunar landers to carry NASA science payloads and other commercial payloads to the moon. And this was essentially like throwing the first seeds or throwing the gauntlet for the seeds of the cislunar economy. There was not a lot of public fanfare around this. A lot of people didn't hear about it, maybe still don't know about it, but it was a critical signal to the private sector to innovate. It was an invitation to innovate. And as a result, 2 private companies have since launched spacecraft to the moon. One successfully landed. I'm going to talk a little bit about that more later too. A lot of people have asked me why. Why are we returning to the moon when we've already been there? And why now? And the answer is simply water. There's water and then there are craters, as they say. And this really is like a new gold rush. So during the Apollo era missions, we thought the moon was bone dry. We had some signs of it in the 70s from Soviet sample returns, but it went unnoticed. In the 1990s and 2000s, early 2000s, a series of missions by the US and India began to detect and confirm the presence of water, especially in the deep craters in the icy poles, which haven't seen sunlight in billions of years. A later mission in 2020 detected water in sunlit areas as well. So we know now that there's a significant amount of water on the moon, and this is really important for several reasons that impact science, exploration, and the potential for establishing a sustainable human presence. It turns out that water is one of the most important materials for radiation shielding and to create breathable oxygen, both of which are critical for human presence, sustained human presence on the moon or anywhere in space. And it also offers significant insight to the moon's geologic processes and other key insights into our understanding of our origins. But from the most significant thing in terms of the economics is that the water can be one of the most valuable forms of rocket propellant, which is liquid hydrogen and liquid oxygen. So going back to those giant boosters, you get a sense of how much propellant is needed to lift a very small amount of mass off of Earth to get out of Earth's gravity well. If you can fill your tanks and launch from the moon instead, where the gravity is 1/6 of that on Earth and therefore requires much less energy or propulsion to get going, then you can go much further on one tank or take a lot more with you compared to launching from Earth. So in short, water and propellant on the moon changes the economics of deep space exploration. It brings Mars and the outer system into much closer reach. So that's one side of this. The other side of this is, and I just want to point out that Artemis is the name of the lunar mission now, NASA's new program for returning to the moon. Artemis is the twin sister of Apollo. So the other side of this is the geopolitics. So we're not the only ones here in the US who think that this is all a big deal. You'll recall that in the first space race, it was really a face-off between the Soviet Union and the US. Now, one of the key aspects of the new space race is that there are many more international players and a key big one, China. India doesn't get as much attention, yet it has a very impressive and growing space program. And I don't have time to go into China's space activities, including the moon and Mars, but suffice to say that they are a formidable contender in the emerging landscape. And that really leads us to a major new aspect of the new space economy, and that came in 2019 with Space Policy Directive 4, and that's the establishment of the US Space Force. So Space Policy 4 formally established or directed the DoD to create the US Space Force as a new branch of the armed forces dedicated to space operations. And Space Force is tasked with ensuring the protection of US assets and interests in space. And the mission is to protect and also encourage, and especially to safeguard economic activities in space. NASA and Space Force have recognized that in international competition for leadership in space, the strongest asset, in fact, is our entrepreneurial spirit and the enterprising culture of this country. So both those agencies are making massive strides to improve the manner and speed in which they partner with the private sector to enhance our capabilities across the entire space regime. And this has been absolutely critical to the success of TransAstra thus far in achieving over $10 million in non-dilutive, highly competitive funding from both Space Force contracts. So this is just a spattering of what this new space market landscape looks like. Launch, of course, is the most obvious one, but it's not just SpaceX. It's many other small launch companies you may not have heard of yet, including Stoke Space, which has the first fully reusable first and second stage, Firefly Space, which has flown successfully multiple times now for Space Force missions, and then, of course, the Starship, which Alex just talked a little about, now has successfully gone into orbit and landed its boosters. Starship can lift between 100 and 150 tons into low Earth orbit with each launch. That's somewhere around 100 roadsters in a single launch. The next area that's really getting going is tourism. You've seen the first missions flown by Blue Origin, their suborbital launches. SpaceX is taking civilians to space station, and private companies are building space stations for research and human habitation, even like hotels for very expensive vacations to begin with. And this is really just the beginning of getting used to humans living and working in space. Other key market segments that are developing, these are very active now. You don't really see them, but the effects are very much felt on the ground, and that's Earth monitoring. These are crucial satellites that are in low Earth orbit, doing climate research, agriculture services, maritime operations. And biomanufacturing is actually an emerging industry that greatly benefits from the magic of microgravity. In the weightlessness of space, the earthbound rules of physics are still in effect, but they have much less impact on or constraints on the way that molecules, that chemical reactions happen and molecules and structures form. And so it really has a favorable impact on the way that we can grow cells. It opens up a whole litany of new possibilities for pharmaceutical research, semiconductor research, optical fibers, medical devices, and nanomaterials. There's also a whole new sector in orbital logistics opening up. With all of these satellites in orbits, we need to be able to deliver them to very specific orbits, move them around, pick them up. There are new networks of GPS coming online, provided by the private sector. This provides a critical supplement and backup to what was once part of the military domain. And then satellite servicing. So satellites servicing other satellites, repairing them, upgrading them, refueling them. And all of this is becoming a new space sector. This is a good snapshot. This is a couple years old now, but it kind of gives you really at a glance the growth that's going on in the various metrics of this market: total space size, annual funding. You can see the number of countries that are establishing space agencies will have doubled in the next 10 years or so from 10 years ago. If you look at the cost of satellites, the middle bottom row there, where you see the dramatic drop in the cost of satellites. And that's really what's fueling a lot of this growth, that accompanied by the number of launches and the cost of launches. So satellites are getting much less expensive, access to space is getting much less expensive, and it's really just opening up a whole new domain. Also, the actual size of the domain is expanding as we start to operate more in the lunar orbits. This area between the Earth and the Moon is called cislunar space. So now we're talking about operations in low Earth orbit, geostationary orbit, but we're also operating more in medium Earth orbit and also in lunar orbit. So this is significant because there's a lot more complexity in the dynamics and the laws of motion as you get near the moon, where a spacecraft is affected by the moon's gravity as well as the Earth's. And so this is also a big emerging area for expertise for space operations and operators. So there's a really quick overview of the new space economy, the why, the what, the why now, who some of the players are. I'll spend a few minutes centering back in on some of TransAstra's active involvement in these areas. So for the reasons we talked about before, activity to, from, and around the moon is growing at an ever-increasing rate. In the last 2 years alone, we've seen multiple successful landings on the moon, including by China, India, Japan, and the first ever commercial non-government landing of a US company named Intuitive Machines. These are all small, uncrewed spacecraft, and our Sutter telescope technology is very powerful, cost-effective systems that are really good at finding small, faint moving objects over large distances. As we described, they were developed for finding asteroids, and now they have become very valuable for Space Force as a commercial supplement to their very large and very expensive and very busy ground-based satellites. And Sutter has now become a very valuable supplement to Space Force's very large, very expensive, and very busy ground-based telescopes. Another one of the essential services, as we hinted at, is debris removal and recycling. So collision with space debris is the #1 catastrophic threat to space missions, crewed or uncrewed. In the center top is the depiction of the SpaceX Starlink planned constellation. And so that gives you a sense of the number of spacecraft that ultimately must be deorbited to avoid the possibility of dangerous collisions. And this is just a single of the mega constellations that are planned. Rocket bodies actually make up about 40% of the large debris population, and other big spacecraft like Starlinks. These are the large debris that are pose the biggest threat to not only spacecrafts in orbit but launches that are trying to get through low Earth orbit. So our capture bag, as Joel described, is uniquely good at safely capturing and containing these large items and bringing them into a disposal orbit, or where they would burn up in the atmosphere, or in the near future, we intend to bring them into on-orbit storage depots for processing. So think salvage yard, where these pieces of junk can instead be repurposed and thus save lots of money on launch costs and really create a new market that incentivizes the cleanup of space debris. And that really kind of segues into our ultimate vision, which is Solar Forge. Solar Forge is the ultimate space boundary. It leverages the unlimited supply of solar energy, microgravity, and hard vacuum in space. And it'll take recycled debris and asteroids and convert those into the constituents that can be used to build large structures and generate propellant in space. So things like water, iron, platinum group metals, silicon, aluminum, you name it. It can process just about, I don't want to say all, but a lot of the materials that would be needed to really establish a robust manufacturing sector in space. And it leverages the unlimited supply of solar power. So these are some of the different things that we can build, but I just want to highlight the one up in the top left, which is space-based solar power. Space-based solar power is still an emerging concept, but it represents a really exciting solution to global energy challenges and offers the promise of sustainable, flexible, and almost limitless power source. It's got a lot of technical hurdles still, But the key ones are actually the high implementation costs, which is about launching solar arrays and transmission technologies. But with the advent of reusable rockets and cheaper launch systems and the potential for in-space manufacturing that we present here, it could really help reduce the expenses and make that a viable solution. So these are just some of the ideas that we are moving forward with very quickly. The other ones are already in operation, and that just provides a little snapshot of what we're doing here to be part of the new space economy.
Great, Nicole. Again, absolutely fascinating. Thank you, all three of you, for this interesting presentations and sharing the concept of things you're working on. I guess the first question I have for you is, I'm absolutely fascinated by the capture bag concept. And have you tested prototypes or other versions of this? How did you get to an actual now fabrication of the test bag that's going to be sent up to ISS and actually tried out in low Earth orbit?
Well, we've been working on capture bags for several years now, actually. And full disclosure, it was not our idea. Actually, two people that I used to work with, Dr. John Brophy at JPL and Professor Fred Kulik, who was my PhD advisor actually back in the day. Fred passed away recently. Came up with the idea of using capture bags to move asteroids for NASA. And actually, NASA and JPL had a mission concept called the Asteroid Redirect Mission that used capture bag. And they came up with that about the time I was founding TransAstra. And I was inspired by it as really a killer capability for asteroid mining. So the first capture bag that was actually built a few years ago under NASA NIAC Phase 3 funding. So we've been looking at it for asteroid mining for several years. And it was actually Nicole, I think, who came up with the idea of using it for orbital debris cleanup and end-of-life disposal a few years ago. And so that's been the primary focus of our engineering work on that since. So we were really lucky. We won a couple of proposals from NASA and from Space Force to flesh it out, which we married together with investor money. NASA has this wonderful program called the NASA SBIR Ignite program, which is a special kind of small business innovative research program that's focused on technologies that have tremendous commercial potential. And so we were one of the first ones to win an Ignite program. And so we won a phase 1 and a phase 2. And then Alex worked with our investors to actually bring in additional investor money, which NASA matched in a phase 2E for NASA. The Space Force looked at that and gave us another phase 2. So altogether, we've had a few $1 million in NASA and Space Force money on capture bag, married up with significant private sector investment. So we have a rich catalog of intellectual property around capture bags, how to use them for asteroid mining, orbital debris cleanup, and picking up uncooperative targets in space.
William, if I could jump in for a second, the prototype that you see over Joel's shoulder, I think it's probably somewhere in that we've done dozens of those already, just in the past 9 months, and we will probably do dozens more before we launch to the International Space Station. So we are a very agile engineering company. We prototype very rapidly.
And I'm looking down that way at the laboratory. And if you look this way, you can see down that way, there's a vacuum tank in the distance and a couple of engineers working on a vacuum tank. There's actually a smaller capture bag in that vacuum tank being tested today also. And that capture bag is actually sized to be similar to the one that will be flying in the Bishop airlock on the ISS, on the International Space Station in 2025.
So exciting. I cannot wait until that happens. I'm sure you can't
I
either.
can't tell you. We are so thrilled. We're so excited about that.
Well, I'm also fascinated by the concept of the solar barge. And have you been doing some preliminary tests or in the development of this concept of processing materials in situ, basically, because you're doing it out in, it looks like it's in low Earth orbit or possibly cislunar. Are there kind of proof of concept experiments that have taken place around processing asteroid materials in space?
Yes. Yeah, so Solar Forge is an extension of one of the core inventions of the company that we call optical mining. So optical mining is this process whereby you have a large, lightweight solar reflector, maybe the size of a tennis court, that concentrates sunlight down into a little circle. And what's amazing about sunlight, especially sunlight in space, is that you can actually concentrate sunlight so much that you can vaporize virtually any material known to science. And so it's incredibly powerful capability that you can harness very effectively in space. Solar concentrators are good on the Earth, and you can do all kinds of interesting things with them. But the problem is on the Earth, you've got atmospheric attenuation, clouds, seasons, all that kind of stuff. In space, at any given moment in space, you get about 1.5 times more power out of the sunlight. It's very steady, unlike with clouds and atmospheric effects. But then if you're in deep space, that's just 24/7, 365 days a year, continuous power available. So one of our early inventions is something that we call optical mining. Optical mining is the idea that you take concentrated sunlight, you hit an asteroid or rock surface with it, and we've shown that you can actually chew holes in it, drill holes in it, and use it to process the materials with no moving parts, no mechanisms, no drills, no digging apparatus. That's incredibly important in space. Solar Forge is an extension beyond optical mining to be able to process virtually all of the elements that are in an asteroid or a spacecraft that you're recycling, where we vaporize it and separate all those elements into their constituents and collect them separately. And Solar Forge is based on a couple of very deep technical insights that we've had. One of them is related to the kind of fractional distillation that's used in petrochemical plants here on the Earth. And the other is actually a quantum mechanical process that Dr. Jim Small, our director of innovation, invented. And we're extremely excited about this. Now, we've done dozens and dozens of experiments with optical mining, both here in the laboratory in Southern California and at an ancillary laboratory that we own at the Colorado School of Mines, where for example, we just had a PhD student finish his doctorate thesis on optical mining. And I was lucky enough to be on his PhD committee.
Absolutely fascinating. So I'm curious about, Alex, you were speaking about the legal issues, and of course, nobody owns a moon right now. And we know that there are tremendous resources out in space. How have those accords evolved, or where do you see them evolving toward as you actually see advances in non-collaborative countries, who are beginning to develop the technology to travel to the moon and beyond? Is there attention on this now in the United Nations? Is this a point of discussion as more and more nations are beginning to engage in exploration of space?
William, space governance is a very almost blank slate right now, and we think about them, we talk about them in terms of laws, regulations, rules, norms, and behavior. And it's kind of it's a scale of laws have legal effect, behavior has there's no way to enforce that, and so we really are looking at how do we enforce behaviors or laws. The United Nations has limited ability to enact legislation that is binding on any country unless that country agrees to it. And so we don't have that, and I don't think we're really going to have hard laws. Is another phrase that some of the literature uses. Hard laws governing these. We might have some rules which have less legal effect. We might have some norms or behaviors that we hope to abide by. But I do think we are at a stage where it would behoove all of us to enact more regulations or laws so that we know, for example, let's take this. A country lands on the moon and wants to extract resources from them, and they put up a fence around that area. Well, how close can another country get to that fence? Can another country take down that fence? These are unanswered questions. At what point does it become a more almost a military issue, where how is one country going to enforce and protect its investment to have, say, extract water from the moon if another nation wants to take it? And these are serious questions that have the ability to strike significant conflict, which I think we would all say we would want to avoid as much as possible. I think this is an open area that we really need to address in order to avoid armed conflict on the moon, for example. But I'll give you another.
Could I jump in?
Yeah.
Yeah, I'd like to jump in there. One thing that we should be very proud of is that the United States is taken an initiative of leadership and collaboration with other countries. And I think Nicole made reference to this, but with the Artemis Accords. The Artemis Accords are an important international agreement led by the United States. It's been signed by, I think at last count, about 50 countries that basically say that these resources are for the betterment of all, and that those who do the work to develop them and can capitalize and benefit on that in a collaborative way. And it's a way to reduce conflict in space. Countering that is the International Lunar Research Station agreement between China and Russia, which is kind of a counterpoint to the Artemis Accords. So we can see this sort of bipolar world developing a little bit. It's a bit of a challenge. When we look on the international stage and look at countries that are good citizens and maybe countries that are not so good as citizens, and you see the kind of activities that China does in the international waters, harassing fishing boats from other countries and that sort of thing. It's something to be concerned about, and it's one of the reasons why the mission of the Space Force is so important. There's debate in space policy about what is the role of the Space Force, but protecting free commerce is core to it also.
Well, I think it was actually fascinating. Alex, I think you were mentioning part of the 1967 Accord, and I was, about not contaminating another celestial body. And of course, that happened, I think, in 2019, right? When the Beresheet crashed into the moon and spread tardigrades on the surface. And that is a risk, right? When other nations are doing experiments and we may accidentally introduce something that could have consequence over time. So I think it's absolutely fascinating. And I think you're right, Joel, that there has been great collaboration, and hopefully that will continue, over time.
William, to your point, that actually shows one of the limitations on the Outer Space Treaty, which is what happens if somebody does violate one of those provisions, and it's not nuclear weapons, but it's to say it's contamination. Who's going to enforce that, and what's the penalty? And this is one of the things when you talk about like theory of law, you want to know, well, what's the penalty for breaking this law? Who's going to enforce it? And that's one of the big constraints that we face in international agreements, because it takes a lot for one country to say, yes, if I do this, I'm okay with another country penalizing me in some way. And so I do think that the answer is collaboration as best we can. But it is a issue that's rife for conflict when you have potentially very, very significant resources available on the moon, just to take one example.
Mm-hmm. Well, something about your business plan that I find so absolutely fascinating is how you're using, if you will, more accessible technology through the Setter telescope, right, to map, identify, and make a plan as to where these asteroids are. We know that we can go to an asteroid and come back. It was proven by OSIRIS-REx, right? We saw Bennu. We found a way to go there, capture a piece of Bennu and bring it back to Earth. So we can do it. That has been proven. So I'm curious, as you are identifying potential asteroids to explore in mind, do you have your highest priority ones already identified, the ones that you hope to first pursue?
Yeah, the short answer is, what are our highest two? Have we identified our highest priority asteroids? The short answer is yes. The long answer is the target set is always changing because we're discovering more asteroids all the time. And as we understand the characteristics of the asteroids that we're studying and the technical approaches that we'll be using to harness those materials and the markets we'll be selling into, it changes which targets we need to go after. But for example, we have our eye on a very interesting target that's going to be in a very good position. I won't say exactly, but in a short number of years, that we think we can do something incredibly historic with, and we're pretty excited about that. As the CEO, I'm allowed to make teasers, but not to give. But I'm not going to give away all the secrets.
That's great. Nicole, you brought up a really interesting point about water, right? And we know the moon now, of course, has billions of gallons of frozen water, and it holds a great promise, not only as a fuel source, but also to sustain life. But there are experiments now around actually growing food that we could consume as humans using regolith, and it's successful. And so it is kind of extending the politics of water, right? And the domain of water and the power of water into space. It's a really fascinating, I think it's a great topic for a sci-fi movie or a fictional book of some sort, the space water wars. What are your thoughts on, do you see a kind of a business opportunity, honestly, with that? Beyond using those resources to go deeper into space and space exploration, is there potentially an opportunity to bring that back to Earth if the economics could work?
So I think there's going to be a tremendous market emerging around using water in space. I mean, the market for propellant alone in space is going to be, even if it's for orbital operations in cislunar space, doesn't necessarily have to be to go to deep space. I think that will probably be one of the kind of highest dollar value commodities from the moon and asteroids, is water derived, that can be used for propellant and, as I mentioned, for radiation protection, and then generating oxygen and just consumable water to support people living on the moon or in space stations, working and living in space. I don't necessarily see it as being a meaningful commodity to bring back to Earth. Someone who maybe is an expert in that and has done that analysis might disagree. But I think there's actually so many valuable uses of it in space that it's going to be kind of snatched up pretty quickly for those applications, and much more readily than bringing it back.
Yeah, so we see a major multi-billion-dollar per year market for water in space opening up in just a handful of years, because water and other volatile materials like water constitute the important ingredients for rocket propellant. So this is an example of our omnivore solar thermal rocket engine. This is our Mark II engine for testing in those vacuum tanks over there. And it uses water as propellant. That's very important for getting around in space. Earth is the pale blue dot. It's the water planet. It's the one planet that you don't need to bring water to. But there are very valuable materials in space that might make sense to bring to the Earth. If you'd asked me 10 years ago, is there anything valuable enough to bring back to the Earth from space? I would have said, like platinum group metals cost maybe an average of $100,000 a kilogram. Probably not worth it based on the cost of space activities. After all, you made reference to the OSIRIS-REx mission. They paid, more than $1 billion for hundreds of grams of material brought back. But there's the big revolution that Nicole made reference to that's happening with New Space, is the massive reduction in cost. A typical JPL lander on Mars cost about $1 million per kilogram to build, or $1 billion for every 1,000 kilograms of spacecraft. But the New Space activities are producing spacecraft that cost more like the same as a laptop per kilogram, on the order of $100 per kilogram. So, take a there, SpaceX has launched, I think at last count, 6,000 satellites into orbit in their Starlink constellation. Reasonable industrial experts have estimated that SpaceX, it only costs them less than $1 million per satellite. Based on the way the old space industry has been doing satellites, those would have been $200 or $300 million a pop 10 years ago. So there's a massive reduction in the cost of going into space, typified by Starlink and the kind of hardware you see in this laboratory. And that reduction in cost is the magic that makes it happen. And so, yes, it does make sense to bring back precious metals from the asteroids very, very soon. And the key to it is the low cost in space transportation, low cost hardware, and the inventions that we're making to make that happen. So there's a multi-billion-dollar industry for selling water in space, for getting around in cislunar space. And there's a multi-billion-dollar industry for bringing platinum group metals back from the asteroids. And at TransAstra, we're dynamic and flexible. We're watching the markets, we're watching the technology, and we will jump into the right market at the right time to make that happen.
Alex, did you have a comment?
Well, I would echo what Joel would say. I would say it a little differently. When you think about whether it makes sense to bring a resource that you obtain in space back to Earth, it's a cost benefit analysis. It's pretty simple. Mm-hmm. And for water, with water being so abundant on Earth and what water costs on Earth, it's relatively small compared to the cost to retrieve it in space and bring it back. It wouldn't make sense. As Joel just mentioned, there is a use case that we see as a potential for certain platinum group metals, where again, it's expensive to extract on Earth, it's in high demand on Earth, and it might be more efficient to extract it from asteroids, for example, and bring it back to Earth.
The fundamental reason for that is that metal asteroids are better platinum group ores than terrestrial ores. They're about 15 times better. And so as soon as the transportation and everything costs are no more than 15 times as much as mining on the Earth, it makes sense to get them in space. And we are right at the cusp of that happening now.
No, I think that's very true. And that's what intrigues me is that, or one of the many things that intrigues me is that the cost, how it's come down dramatically, and that's going to make it accessible. And I kind of use as a analogy what happened in aviation, over 100 years ago, where it really was a wealthy person's pastime, right? The beginning days of aviation and just how it's advanced to be just a common form of travel. The other thing that intrigues me with the concept of mining water in space is we know that water is prevalent in the solar system. You go to several of the moons of Jupiter. Maybe that is a way to get into deeper space. Do you somehow be able to source the water from Enceladus or Titan, one of the moons of Jupiter, so they're the technologies that we don't know about yet. It's one of the things I loved about John F. Kennedy's moonshot speech in 1962. We had only sent Alan Shepard 500, feet into the air. He hadn't gone very far, hadn't even really gone to space. And he was saying that we're going to send a man to the moon and bring him back safely in a decade, right? With technologies yet to be invented. So we have to consider that there are technologies we're advancing and inventing that we haven't even conceived of yet, that are going to continue to advance exploration and opportunities for humanity.
Well, we're working really hard to conceive them and reduce them to practice here. And as far as you're absolutely right. Everywhere you go in space, there seems to be water. And we know that the asteroids are spread all the way from just grazing the outer surface of the sun to beyond Pluto. And what's exciting about the asteroids is, yes, they're loaded with water and other volatile materials like carbon dioxide, carbon monoxide, but they're loaded with almost everything on the periodic table. So wherever we go in space in the next 1,000 years, the asteroids will be right around us as refueling stations and resupply areas for building our habitats, building worlds that we can live in, building the ships that go between the planets.
Absolutely fascinating. I regret the fact that we are running short on time, and I have to draw our conversation today to a close. But before I do that, I want to give each of you an opportunity to share any closing thoughts or comments you'd like. And maybe we'll start with you, Nicole.
So I think one of the most compelling and fascinating things that's going to emerge over the next few years is a sense that the moon and is not this sort of very separate thing from the Earth. The Earth Moon system is a very interconnected system, and the asteroids that are in near Earth like orbits are extensions of our ecosystem. And I think we're going to start to see a broader perspective and a broader understanding of what actually our natural ecosystem is. And that includes the moon and the near Earth asteroids, and that these are actually parts and pieces of the universe that form that are very close neighbors, and they affect our lives on a daily basis, whether we realize it or not. And they're very much part of the world that we live in. And if we're able to understand how to work with those resources in a way that's actually less impactful to our biosphere, it presents a tremendous opportunity for the population here on Earth. And so I don't see it as a this or that sort of scenario that a lot of people do, Earth or space. To me, it's just sort of an increasing awareness and understanding of what our natural ecosystem actually is.
Thank you. Fascinating. Alex, your final thoughts.
Yeah, William, I'm going to take this from a little different perspective, and that's just for all of the young men and women. I count myself in that category, who have decided to work in the space industry. It is not without risk, for sure. It's not for the faint of heart, and you have to have an adventurous spirit to do it. And most importantly, you have to be an optimist at your core. And at TransAstra, we are filled with adventurous spirits and optimists. I tell people all the time, there's never been a better time to be a human being on this planet than right now, with the exception of maybe 50 years from now. It'll be better 50 years from now, and it'll be better 100 years from now. But at TransAstra, we are optimists. We are very optimistic about the future for our company and for the future of all of humanity.
Wonderful. Thank you. Joel, I give you the final word.
Wow, how do I top that? That was great, Alex. Yeah, we're optimists. We're humanists. We believe in humans. We think that sustainability isn't enough. We have to be sustainable and exponentially accelerating into the infinite future. Space is the final frontier, the high frontier. It's limitless. It is the resources that will allow our children and their progeny into the indefinite future to thrive. It is a way that Earth can thrive in the presence of humans because we'll be harnessing the resources of space. Eventually, all the products that are made on the Earth will be made in factories in space and gently brought back down to the Earth. But most people in 1,000 years will live in space. And the Earth will be a park where people remember that's where we came from.
Absolutely amazing conversation today, and thank you so much for the presentation. I'm extremely impressed with the work that you're doing and look forward to keeping track of all of your inventions and also how your experiments roll out on the International Space Station. It's coming up very, very, very soon. And so want to say that we're concluding our program today, our Thought Leader series on engineering the future of space with TransAstra. My heartfelt thanks to Joel, Nicole, and Alex for joining us today. To all of our participants watching our program, thank you so much for joining us. And please tune into spacecenter.org, visiting at our website to learn more about our future programs and to watch this recorded episode again in the future. Thank you for joining us.
Great. Thank you.
Thank you so much.